All right, so section 3.7 is going to discuss polynomial and rational inequalities. Now, the way we're going to approach this stuff is I'm going to show you how to do the mechanics of this, of testing points with a graphing calculator or Desmos for some simple problems first, and then we're going to apply them to harder problems. But the idea is that you want to learn kind of the pattern, the way you work on these things with the easier problems, and then we're going to apply it to the harder problems. Now, the easier problems, you can almost visualize the solution. But let's try and pretend that we've got a harder problem that we want to understand the general flow for that. So this is an example of a polynomial inequality. In this case, it's a quadratic polynomial. So, okay. Our goal in solving this is to try and figure out what intervals along the x-axis make this true. So your answer will be in intervals along the x-axis. Okay. Now there's a sequence of steps that you're going to follow in order to do these types of problems. The first thing you need to do is get 0 on one side. This is crucial because the way we're going to work this is we're always going to look and try and figure out is something positive or is something negative. So, okay. So that's pretty easy. You're just going to move the 1 to the left-hand side. And then you want to figure out, well, where is that expression actually equal to 0? So you want to find the roots of this. That's not too hard in this particular case because it's just a polynomial, and in particular it factors. So, okay, set each factor equal to 0, and we get a couple roots. Your roots at 1/3 and -1/2. So, okay, those are our roots. Let's put those roots on a number line. So, let's see, -1/2 and 1/3. Now those roots break up your number line into intervals. And we want to kind of acknowledge what intervals those are. So after you put those numbers on, let's label the intervals found from that above step. So this is the stuff where you're labeling intervals along the x-axis. So it's -∞ to -1/2, -1/2 to 1/3, and finally 1/3 to infinity. Bless you. So those are the intervals. Your answer to this problem is going to be one or two of these intervals. We just don't know which ones yet. So we got to spend a little time and figure that out. Okay, cool. Now, the way we're going to decide which interval is we're going to test points in each of these intervals. So we want to figure out, well, what's a good test point in each of these intervals? So that's what we're going to do next. So I need a value of x that's between -∞ and -1/2. -1, sure. How about something between -1/2 and 1/3?
0.
All right, so we got our test points. -1, 0, and 1. Sure. Now these are going to be our test points, and we're going to test them in this expression, 6x squared plus x minus 1. That's the expression that we want to test them in. That expression comes from up at the top. That's where you got, 0 on one side. It comes from right here. So you're either going to enter in that expression into Desmos or into your graphing calculator. I'm going to start with the graphing calculator and do things there. So let me clear this out and clear this. Let's get rid of this. So it's going to be 6x squared plus x minus 1. Nice. Now I want to put my test points into this to see where the function's positive and where it's negative. The first thing you might want to double check for yourself is that you've got the right table set up. So you hit the second key, then the window key, and make sure that independent is set to ask and dependent is set to auto. Those settings should be all there for you. If they are, great. If not, then fix them. I'll hit the second key, then the graph key. That brings me to the table function. I'll delete all that stuff there. And let's just type in the points that you suggested, -1, 0, and 1. And let me just go back and double check that I'm sharing my window. All right. Now, the information I need here is not that when I plug in -1 in the function, I get a +4 or a -1 or a 6. The only thing I care about is the sign of this. Is it positive or is it negative? That's all I care about. The actual magnitude doesn't really matter. So what we found here is that this tested out to be positive, negative, positive. So let's just kind of squeeze it in here. Positive, negative, positive. Now let's look back at the original inequality here, at least this one, where I had 0 on one side. Do I want to know where this is positive, or do I want to know where it's negative? Which one of those intervals is going to satisfy the inequality? The positive intervals or the negative interval?
Positive.
Positive, yeah, because you want to know where it's greater than 0. Where it's bigger than 0 is where it's positive. So this and this, those are my answers. And that's it. We're done. So your answer is -infinity, -1/2, union 1/3 to infinity. Nice.
Yeah, should it have brackets on it?
It's a great question. Should there be brackets on it? And the answer in this case is no, because this is a greater than 0. But you bring up a great question. Should it have brackets on it? We will look back at this kind of thing later on when we do some more examples where this is greater than or equal to or less than or equal to. It will make a difference. Now, in this case, if it was a greater than or equal to 0, then I'd have brackets here at the -1/2 and a bracket at the 1/3. With this example in particular, though, you don't necessarily need to do this one with this kind of mechanical process, because you can already envision what the graph of this looks like. It's going to be a parabola. It has to face up. You know where its roots are. And so you know already that, gee, it's going to go positive, negative, positive. It's not a big surprise there. So if you were good enough with this, you could probably do that without having to do all these testing of points. The bummer is, though, you're not always going to get such nice, simple polynomial inequalities. They're going to be a little bit messier. And in general, what I suggest is you just get good at this testing of points thing, because that's the way it's going to be very methodical and easy for you to do these things beyond just this very simple intro example. All right, so are we okay with our first example? All right. Let's try some more here. So let's move on down to example B. And I think I've got a Desmos link that goes along with this. So let's just open that up. Inequalities, I can shut these down and go back up to here. Now, the last one I did using graphing calculators, this one I'll do doing Desmos, but let's take a look at the original inequality. I want to know where the product of these things is less than 0. Okay, fair enough. Let's start by figuring out where this actually equals 0, because remember, those are the things that we're going to do here. Get 0 on one side, check, got that done, find the roots and factor the other side. Okay, you should be able to read off to me where this is actually equal to 0. 6, -8, and -8/3. Perfect. Okay, so if it's equal to 0 there, let's put those on the number line and see what happens. So put those on the number line. Now you need to put them on in order from lowest to highest. So it'd be -8, -8/3, and 6. Great. Then what?
Like the intervals.
Perfect. Thank you, Sydney. We want to write the intervals. So the intervals that I get here, that'd be what? What's to the left here?
-infinity to -8.
-infinity to -8, and -8 to -8/3, -8/3, and 6. David, what's the last one?
6 to infinity.
Awesome, thank you, sir. All right, so those are our intervals. I need some test points here. Sean, give me some test points here. What would be some points in each interval that I could test?
I use -10, -4, 0, and 10.
Perfect. -4, excuse me, -10, -4, 0, and 10. Now, if you're going to test this on Desmos, the easiest thing to do is to write that polynomial. And let me show you the whole bit of it. So I wrote that polynomial, but I gave it a name of g of x. Now I could give it a name of y, but if I give it a name like g of x, then I can test points just by typing in, for instance, Sean suggested g of -10. Okay, there you go. G of -10 is -704. But what's the information that I actually need out of this? Do I need that it's -704? Go ahead.
Negative or positive.
It's negative or positive, yeah. So in this case, it's negative. So, all right, let's keep going. We've got negative, and then -4 was next. Positive. 0 is always a good one, I like that. Negative, and then finally positive. So what happens quite often is that these will alternate in sign. They did in this particular case, that's great. So let's see here. It was negative, positive, negative, positive. Do I want the positive intervals or do I want the negative interval?
Negative.
Negative, good. So that means I want this one and this one. Now the reason I suggest you write these intervals here is because it's very easy when you're picking up your solution to make up your intervals with your test points as opposed to the endpoints of each interval. I see that all the time, and it's frustrating for me because I think you know what you're doing. So this is a worthwhile step here. I encourage it. All right, so our answer then is going to be -infinity to -8 union -8/3 to 6. I know those are with parentheses because this is a less than. It's not a less than or equal to. Are we okay with that one there?
Yep.
All right, got a couple doing good. All right. What would happen if this was a greater than or equal to, as opposed, or excuse me, a less than or equal to, as opposed to just a less than? So if you had x minus 6 times x plus 8 times 3x plus 8 is less than or equal to 0, how's that going to change things?
You're gonna need some brackets.
Yeah, we're going to need some brackets. Thank you. So it's going to be negative infinity to negative 8 with a bracket, union, negative 8/3 to 6, again with brackets. So all your finite points would then have brackets. So you're going from here to here. So it's just something to be aware of when you're working on these kinds of problems, is that if this is a less than or equal to or a greater than or equal to, you got to think about the brackets and where you might want them. Okay, let's move on down to example C here. See what's going on there. Kind of like the previous ones, you're lucky in as much as they've given it to you already factored with 0 on one side, so it's a nice little bit of a head start here. And let's see, well, let's draw ourselves a little number line over here. Ella, can you tell me where this is actually equal to 0?
-5
Good?
twice,
All right,
Does
well, we
this-
only have to list it once, so -5,
-2 and 1.
perfect. -5, -2, and 1. Jason, what are the intervals that I get here?
Negative infinity to -5,
Mm-hmm.
-5 to -2,
Good?
and then -2 to 1,
Mm-hmm.
and 1 to infinity.
Perfect. So those are my intervals. Great. Patty, I need some test points.
-10, -4 again, that would work.
Yeah, I was curious if you're going to make Sean's points work again.
Yeah, they do.
That
And
is-
0 would also work, and then +10 would also work.
Yeah, all right. So Sean, she's borrowing off of you. So no, it's okay. It works. Yeah, it's kind of interesting that those same points actually work again for us. Let's test them in our graphing calculators, or you can test them in Desmos, whatever works. But try and work on those. I'll show you the setup in Desmos. So let's see. I'll shut this one off. I wrote this one with f of x. I think the link that I might have had out there might have this as a y. But every time I update this, it gives me a new link, and I just can't always keep up with things. In any case, test your points, starting with -10, and then see what it gives from there. I'll kind of walk around and help out. If you're watching this later, this is a brief pause. You can skip past it. So which one do you want?
This one, so I did.
Be a little bit careful about what happens around the
Look with your eyes that way, that's what it is.
For a moment, at -5 it actually equals 0, so you can't have -5. It's a little tricky, Emily. Thanks for the.
You got it? That way.
Thank you, I didn't see it come, so that's why I did it.
Yeah, except you can't go from -2 to I'll talk about that. Did you figure out how to get those testing points?
This is literally an hour ago. Yeah.
Just wanna make sure. So what'd you have up? Positive negatives. Yeah. to adjust that. I'll talk about why. You and Sean are on the same wavelength. You have the answers, you can't. Yeah, I gotta talk about, because it would positive, positive, negative, positive, right?
Yes.
Okay. All right. Nick, did you get positive, positive, negative, positive? Okay, thank you. Okay, so if you actually did go through and test all the points, what you would see is you get positive, positive, negative, positive. And let me just pull it up here real quick if I can. There's negative 10, and then negative 4, and then 0, and then 4. So we get positive, positive, negative, positive. Now what's unusual about that is that usually when you do these things, the signs alternate. Usually you get negative, positive, negative, positive. You see that and everyone's really happy. But this time it went positive, positive, negative, positive. It didn't exactly alternate. So what's going on with what's happening right here? Well, remember, there was 3 different types of behaviors that you could get of a function near a root. What were those behaviors? Remember from the last exam, Nick?
Bounce, wiggle, and straight through.
Beautiful. Bounce, wiggle, and straight through. Thank you. What's the behavior of this function at x equal negative 5? It's going to be a bounce. So instead of going through the x-axis and changing signs, so going from negative to positive or positive to negative, it touches the x-axis and then bounces back the same way. So it's the same sign on either side of negative 5. So my solution should be all the intervals where it becomes positive. So my solution would be negative infinity to negative 5, and then negative 5 to negative 2, and then 1 to infinity. So all of those. Now, a good question would be, well, why can't I just go negative infinity to negative 2, right? I mean, save myself a little bit of writing. Not quite. Remember, I want this to be greater than or equal to 0. If I did negative infinity to negative 2, I'd be including the number at negative 5. What happens if I put in a negative 5 into this expression? What would I get? I'll tell you what, we can just do it, right? You know, and you can think about it, or I can just do it. Let me put in a negative 5 here, and I get 0. All right, not a surprise in hindsight, I think. I get 0. Is 0 greater than or equal to 0? Or excuse me, is 0 greater than 0? No. So I can't use that one point. I can't use the negative 5, which is kind of frustrating because if I could, man, things would be a little easier. But let's come down here to the next part. It says, what effect would it have on your answer if the inequality were greater than or equal to? So if I had x plus 5 squared x plus 2, x minus 1 is greater than or equal to 0. Now let's think about what happens. Now I go negative infinity to negative 5, but I put a bracket, and then negative 5 to negative 2, bracket. And then I start looking at this and going, you know what? I could have written this a little bit better. What would that be?
Negative infinity to negative 2.
Negative infinity to negative 2, a bracket. Now I'm not really sure what WebAssign would do with this answer. I mean, in my way of thinking, it's right. I wouldn't mark it wrong if you did it for me. But this is probably what it's going to be looking for. Is, oh, okay, we'll just use everything from negative infinity to negative 2 there.
Wait, did you say you'll mark it wrong if you do it the Knox way or the formal way?
I'll give you credit either way. I'll be really happy if you get the right answer, even if it's a little bit more cumbersome than it needs to be.
Oh, but it's only for if the sign is the equal to.
Yeah, if you include the equal to. Now, there's really no negotiation if it's a greater than. you have to have two intervals around that -5. You can't include the -5. But other than that, if it's greater than or equal to, I guess there's a couple options, both of which will work. All right, are we good with polynomial inequalities? All right. Let's try rational inequalities. So that's the flip side of your handout. The way I constructed these things is so that you're more or less doing the same kind of steps here and there. Now, the problem with trying to always do these things visually is that, you know, if you take a look at the graph of example B, for instance, it's kind of tough to tell where it's positive or negative. You have to have a little bit of skill with your Desmos or graphing calculator to be able to do it like we did with our first example. So we're just going to ignore what the graph looks like for now and just focus on testing points. So that first part was really to get you in the flow of testing points. And let's continue that with our rational inequalities. Now you might notice that in the name rational, the root is ratio. And ratio is a mathematician's way of saying fractions. You've got a fraction here. Okay. Well, that means a couple more steps than what we had with the front side of this handout. We are still going to get 0 on one side. Great. But then you're going to have to write the left-hand side using one fractional term. And here I want to do something for you. I want you to put in your notes. If I write it with one fractional term, I'm going to need to get a common denominator. Get a common denominator. And that's what I'm doing right here. I'm multiplying so that both of these terms have the lowest common denominator. Okay, that's great. And then that gives me my common denominator, so what I'll do is I'll simplify and then simplify some more in the numerator. Now what's left in the numerator after I gather together like terms? Noah?
5x plus 7. And 5x.
Alright, so let me write it as this way, 7 minus 5x. You can write it as negative 5x plus 7. Both ways work fine. Great. This is what you want to get to. You want to get something on the one side and 0 on the other side. And that's where you're going to be testing points. So, test points in here. But before I get to that testing of points, I got to know the intervals where I'm going to pick my points. Where are those? Well, you're going to need to find the roots of the numerator and the roots of the denominator. That's going to be where you're going to be testing your points, is in and around those numbers. So the numerator equals 0, that's where 7 minus 5x equals 0, or 7 equals 5x, or 7/5 equals x. So I get 2 points here. 1/2 and 7/5. So I'll put those on the number line. Okay, happy there? And then what?
Find the interval.
Yeah, just like the last types of problems, we want to find the intervals. Now Noah, what are the intervals here?
Negative infinity to 1/2,
Negative infinity to 1/2.
1/2 to 7/5,
Good.
and then 7/5 to positive infinity.
Excellent. Now, I really hope that you guys get a good habit of writing these down now, because once you put in your test points, it's really easy to mix up, what your answer is going to be. All right, thank you. Let's keep going. I need to test points in each of these intervals. So, let's see. Robert, I need some test points.
1. 2. Oh, a big one, right?
One would be in this interval,
0.
0,
8.
8,
Yeah.
sure, yeah. If you're looking at 7/5 and going, well, I don't know, like, you can pick a big number just to make sure that you're past that point in the interval. Awesome, thank you, Robert. Now let's go back and do this with our graphing calculator. I'm going to clear this out. I'm going to remind you there's really two ways you can enter in this expression. It's kind of up to you. The first way is kind of way a lot of people would do it, with parentheses around the numerator and parentheses around the denominator. So 7 minus 5x, and then a closed parenthesis divided by, and parentheses again, 2x minus 1. So if you're chasing me with your own calculator, then you can take a look at the keystrokes that I hit here, see what's going on. Now there's another way you can do this, which is maybe a little bit more user-friendly if you can remember one thing, and that is how to write fractions on your calculator. So remember the trick on where to find those? Nick's saying yeah. He's like, yeah, I got this. What do you got to hit?
Oh, me?
Yeah.
Oh, second, then X.
Alpha,
Oh, alpha.
and then y equals. And the first selection there allows you to do a fraction. So we'll type in 7 minus 5x over 2x minus 1. Now you only need to do this once. I'm just reminding you how to do it both ways so that you can choose whatever you find most convenient. Now Robert was kind enough to give us some test points. So let's go up to our table and test in some points. And I think we wanted 0, 1, and 2. Beautiful. So negative, positive, negative. That's the information that I need there. And this is kind of what I want to see on your exams too, is you testing points. And I don't care about the numbers, I care about the signs. So negative, positive, negative. That's what it tested out to be. Let's go back to this inequality here. Hattie, do I want the positive intervals or the negative interval?
You want the positive ones.
Yeah, I want the positive one. So that's going to be the 1/2 to 7/5. There's something a little bit different about this one that we didn't have going in our last one. So I'm going to do a little experiment here. I want to know where that polynomial is greater than or equal to 0. So what if I typed in a number like 7 divided by 5? Right? I want to see what happens there. And oh, I got a 0. Can I use that? Is 0 greater than or equal to 0? Yeah. Yeah, we're good there. What about 1/2? So I'll just type in a 0.5. Wait a minute. Are you getting an error? Is that really? So it's not just me, right? All right. No, it's not just me. This is actually pretty predictable. What's happening that 0, or excuse me, 1/2 is giving me an error? Julian, what happens when you put in a 1/2 here?
Makes denominator 0.
Yeah, it makes the denominator 0. And so you end up dividing by 0, and that's a mathematical no-no. It's a big problem. You can't divide by 0. So I'll use a bracket around the 7/5. But Jacqueline, what should I use around the 1/2? Parentheses. So this is 2 points on a long problem. So this is like maybe a 7-point problem. There's 2 points here at the end for getting the brackets and parentheses straight. So make sure you take the time on that to get these right. And there's nothing wrong with testing on your graphing calculator or decimals. Test the endpoints. If it's giving you something that's undefined, that's kind of telling you, all right, you should probably be using a parenthesis there. All right, there's a nice example to kind of warm up on rational inequalities. Comments on this one before we try some more? No. You don't sound particularly happy about it. I don't understand. Math is fun.
You want to type it in the calculator again?
Yeah,
With the fraction thing, all that.
yeah. So, let me go here and I'll clear this out. If you hit the alpha key, then the y equals key, the first option there, just press enter or the number 1. That's what allows you to type in things in the form of a fraction. So 7 minus 5x, that kind of thing. All right.
Okay.
Nick?
Would there be any difference in using, getting a fraction that way and the other way?
No. The interesting thing about this one, and let me see if I can show it to you, is that on the one hand, these all worked out to be nice integer values, but if I type in a number like 0.1, now it's 0.12 maybe. On the one hand, I'll get a decimal value from 1, the other one, I'll get a fraction. So, it's still giving me the same information, essentially. That is, both these show me that I got a negative value when I type in that number. So that's the only real substantive difference for you. So if you want a decimal, type it in the first way. If you want a fraction, type it in the second way. So yeah, great question. Thank you. Let me keep going. So let's turn our attention to the handout then. On the back side, we'll jump down to example E. Now again, this is kind of a nice one because you've been given an inequality that's already got 0 on one side, and it's already factored, and it's one nice, neat, rational expression. So the question is, where is this greater than or equal to 0? Well, to start answering that, there's a couple things we're going to have to deal with first. I want to know where the numerator equals 0. So that's where 2x plus 3 equals 0. Or basically x equals negative 3 halves. Oops, off the screen on that one, sorry. How about the second one? It's where the denominator equals 0. Or x squared plus 4x minus 21 equals 0. I'm hoping that you can factor that one without too much grief. How's that one factor?
X plus 7, x minus 3.
Perfect. X plus 7, x minus 3. Way to go, Robert. So what are my solutions here? Negative 7 and 3. Perfect. Let's put those on a number line. It'll really screw you up if the numbers you put on the number line aren't in ascending order. So make sure that you take care of that. So it's going to be negative 7, negative 3 halves, and then 3. Let's put our intervals down here next. That's going to be negative infinity to negative 7, negative 7 to negative 3 halves, negative 3 halves to 3, and 3 to infinity. You're always going to have one more interval than you have points. 3 points, 4 intervals. 4 points, 5 intervals. All right, I need some test points. Somebody help me out with some test points. Ella, what would be some good test points for us here?
I mean, can't we use our favorites, -10, -4, 0, and 4.
Let's see, -10, -4, 0, and 4? Yeah, those work, sure. All right, so let's test those. Now we have to test them in their proper interval, but I think it'll be okay. Or is it proper in an equation. Now let me go back and do this one in decimals, just to keep on toggling back and forth a little bit. Let me get rid of this and jump down to example E. Now, I don't know as though the link that I shared is completely up to date, because when I make small changes, it changes the link. But I called this function h of x. You can't keep on calling things f of x or g of x, because after a while Decimal's gonna say, wait a minute, which h or which g do you mean? So I keep on giving them different names, but let's test your points. H of -10. Let's see. Maybe I'm just guilty of what I just said here. Yeah, I am. All right, so I got to give this a different name. Let's call it, let's go with J. I like the letter J. So J of -10. What's the information that I need to get out of this?
Positive or negative sign?
Yeah, is it positive or negative? Now, if you want to, Decimals will write it as a fraction for you, which is kind of cool, where it can. But all I need to know is it positive or negative? In this case, it's negative. Next one I want to look at is -4, positive, then 0, negative, and then 4, positive. So it's more of a typical problem in this respect that they alternate in sign. So it was negative, positive, negative, positive. Which intervals do I want? Do I want the positive interval or the negative ones? Positive. All right, so that's going to be this one and this one. Great. Now, let's be careful about the endpoints. And if you're not sure about the endpoints, you can actually just go through and test them all in Desmos and see which ones you want to use and see which ones you can't use. So if I were to do that, let's see, it'd be J of -7. Oh, undefined. Better not use that one. J of 3. Oh, again undefined. How about J of -3/2? -3 divided by 2. Oh, I can use that one because it gives me a 0 in the numerator. I can't use the ones that give me a 0 in the denominator. You don't want to divide by 0. So the two values of x that were where the denominator is 0, I can't use those. Overall, my solution is going to look like this. -7 in a parenthesis, the -3/2 in a bracket, and then 3 to infinity. Noah, am I going to use a bracket or parenthesis around the 3?
Parenthesis.
Parenthesis, nice. Because I can't use the 3, I can't use the -7. Those put zeros in the denominator, so these can't be part of my solution. Beautiful. All right. How are we looking on example E? Doing okay there? All right. Let's keep going with example F, and there's something annoying about example F. When you set the numerator and denominator equals 0, the denominator equals 0 is going to be a little bit more of a pain. So the numerator equals 0, that's pretty easy. That's just x equals 0. Where's the denominator equal 0? Well, that's gonna be a little bit more work. Equals 0, yeah. X squared plus 2x minus 1 equals 0. You're gonna have to use a quadratic formula. So I'm gonna put that on a separate sheet here. X squared plus 2x minus 1 equals 0. A, B, and C. 1, 2, and negative 1. X equals negative 2 plus or minus the square root of 2 squared minus 4 times 1 times negative 1 over 2 times 1. So I end up with negative 2 plus or minus the square root of 8. And I wish I could tell you that you were done, but the square root of 8 breaks up a little bit more. This breaks up into negative 2 plus or minus 2 square roots of 2 all over 2. And those 2's look like too much fun, so we're going to have to take care of some of them a little bit. Let me give you one easy way to do that, and that is divide both terms in the numerator one at a time by that term in the denominator. You'll end up with negative 1 plus or minus the square root of 2.
You have to show that stuff, like the one you just,
If you can go from here to here in your head, that's fine.
okay.
I mean, there's a couple ways you can get here, but get here you should. Now those are the values that we needed. Negative 1 plus or minus the square root of 2. So negative 1 plus or minus the square root of 2. Ugh. That makes this a little bit uglier. It is what it is. Let's put those numbers on the number line and do our testing of points. I'll give myself a generous amount of room here. So I get negative 1 minus the square root of 2, 0, negative 1 plus the square root of 2. You might want to do yourself a favor and figure out some decimal values for these things. That way you know where to test points. So it'd be negative 2.414. Somebody could check me out on that one. And this would be 0.414. Does anyone understand why I put down the decimal values for these things?
Because it's easier to see what your interval test points are gonna be.
Yeah. It's a lot harder to go, okay, well, I need a value of x that's greater than that without knowing the decimal value here. So by knowing the decimal value, I can come up with test points a little bit easier. Now I'm going to violate my own rules. I'm not going to write down all the intervals because I want to finish with this one and do the last two. And I'm also going to help out a little bit. Pretty sure these are going to test out negative, positive, negative, positive. So negative, positive, negative, positive. So we'll see if we can't just write down the answers. Let's see. In the interval here, to the left of negative 1 minus the square root of 2, this is going to be negative infinity to negative 1 minus the square root of 2. Am I going to use a bracket or parenthesis around that point?
Brackets.
Parenthesis, because that makes the denominator 0, so I can't use that one. All right, but I appreciate your enthusiasm. Thank you. Union. Then I need this one. 0 to here. 0 to negative 1 plus the square root of 2. Bracket or parenthesis around the 0?
Bracket.
I'm going to vote for bracket. What do you think? Is there agreement on this one?
I'm always for bracket.
Yep, bracket, yeah. Always inclusive, that's a good thing. All right, so 0 there. And a parenthesis here because we want to include that point is where it's actually equal to 0. So your final answer in this one is all this stuff right here. That's for that one there. Nice. Okay. Two more, starting with example G. Let's see, this was, for example, F. And for example, G. It says find all values of x for which the graph of f lies above the graph of G. And let me translate that for us. F of x is 1 over x. G of x is 1 over x minus 1. I want to know where is f greater than G. That's what I want to know. Now in terms of the functions, that means where is 1 over x greater than 1 over x minus 1. Okay, and that, this point is a rational inequality. So this is what I want to try and solve. Now this one is one that I wanted to get to because it's got an extra step that we didn't have with our previous problem. And that is, I need to get 0 on one side. That's not so hard, right? It's just 1 over x minus 1 over x minus 1 greater than 0. But now I actually got to do some real work. What is that real work that I got to do on this problem?
The denominator has to be like an LCD.
Yeah, we need to bring those two together. We need to find the lowest common denominator. So let's start out by inserting what the LCD is. Anyone tell me what the LCD is? Ella? No, Angel?
X times x minus 1.
X times x minus 1. Perfect. So I'm going to rewrite that. Ella, I'll get you on the next one. She's really happy about that. I can hear your inner child's doing somersaults. All right. So if I want to have the LCD here, I'm going to multiply this by x over x. I'm going to multiply here by x minus 1 over x minus 1. All right, so that's x minus 1 over x times x minus 1 minus x over x times x minus 1. Yeah, just greater than 0. These have common denominators now, so I can combine them and figure out, what expression I've got. And when I combine these, what's left in the numerator after I take x minus 1 minus x?
-1.
-1. Yay. So let's find out where the numerator equals 0. Does -1 equal 0?
No.
Nope. No solution. How about x times x minus 1 equals 0? That one's got a couple solutions. Yep, 0 and 1. Okay, great. Let's take those back to the other side here. So let's write ourselves a little number line. And let's put our points on here. 0 and 1. And I'm going to go back to my typical habits. Negative infinity to 0, 0 to 1, 1 to infinity. Jason, I need some test points, please.
-1.
-1, 1/2, and 2. I heard somebody asking for us to pick 8.
No.
Don't,
All right, we'll pick 2. Thanks for almost biting your tongue on that one. Now, let's see here. If we test that in there, let's see, do I have that already in here? Do you want to test it in decimals or on the graphing calculator? Doesn't matter to me.
Calculator.
Calculator, all right. Let me clear up a bunch of this stuff. So clear that out. Let's clear this and this. So I'll do -1 divided by parentheses x, and then another parenthesis, x minus 1, and then 2 sets of closing parentheses. Now you can do the fraction trick as well if you do the alpha and the y equals key. That's fine, nothing wrong with doing it that way. Then you just put the -1 in the numerator and x and parentheses x minus 1 in the denominator. Great. Either way you want to do it, it's fine. We've got our test points. Let's delete all these old ones so that we doesn't confuse ourselves. And I want to test -1, 1/2, and 2. So it goes negative, positive, negative. Let's take a look at what we got. Negative, positive, negative. I wanted to know where f of x was greater than g of x. That turned into this, which turned into this. So I want to know where that's greater than 0. This is what we tested. So do I want the positive intervals or the negative interval? Or positive interval or negative intervals? Positive. Hey, thanks, Jesse. Test this expression. Yeah, so I want the positive interval, which is going to be 0, 1. Brackets or parentheses?
Parentheses.
Parentheses, yeah. That's it. Just right there. All right. Whew. All right, so we did this one on the graphing calculator. That means we can do the next one on decimals, which is really super convenient because it works out on decimals a lot friendlier. Now you can do this on the graphing calculator. If you wanted to try and do that, you'd want to program in this expression and then also program in another one with y equals 40. I'm not going to do it there. I'm just going to do it on the decimals. So, by the way, here's kind of a little test that you can do. If you rewrite something, if you're like, okay, here's h of x, and then I rewrote it like this. If you want to know if these expressions are the same, it's like, did I get it right when I rationalized this and got common denominators? Graph them both. What should happen when I shut off this graph and turn on this one? Should they be related somehow? Should look identical, right? There you go. So one right on top of the other. So that's telling me I did the correct work. Yes, ma'am.
So can you remind me how you got the greater than 0? I understand that it said f lies above the graph of g.
Right.
Is that?
That's exactly where it came from. So going back to the previous example, we wanted to know where f lies above g. That's the same thing as f being greater than g. So that's this part right here, which translates into this, and it's from here that we did all our work. I move this to the other side. but it's a greater than. Thank you. All right, so to kind of familiarize ourselves with this one, a highway engineer develops a formula to estimate the number of cars that can safely travel a particular highway at a given speed. That speed we're going to call x. She finds that the number of cars that can pass a given point per minute is modeled by this function. So the question is, if the number of cars that pass by a given point is greater than 40, at what range of speeds can they travel? So this is kind of a fancy way of asking a rational inequality type of problem, but I want to know where this is greater than 40. Now what we'll do, instead of doing anything kind of crazy with this, is I'm just going to graph both of these. So let me go back here to Desmos, and I don't think I need to have this so far out. I'm going to graph, first of all, the function that they gave us, and maybe I need to zoom out a little bit. There we go. And then I'm also going to graph y equals 40. So now I've got both of these graphed. And the answer to this problem is just knowing where the graph of n of x, and I used s, but where does the graph in red lie above the graph in blue? Yeah, between these 2 points, right? Now you're going to answer in terms of intervals along the x-axis. So the answer that I see is 9.454 to 42.311. That's almost it. It's just finding, well, where's the red graph taller than 40? So let me write those down. 9.454 and 42.311. Annoyingly, you might get this wrong if you entered those values into decimal or WebAssign. They want you to round your answers to 1 decimal place. So if I round those, that should be about 9 point what? 9.5 to 42.3. If you round it to 9.4, you might get it wrong. I do have a tolerance built into WebAssign, but I don't know if it would exceed that or not. Nice, nice. And like I said, if you wanted to do that with your graphing calculator, the only difference would be that when you graphed it, you would actually have to find the points of intersection using the second key, then the calculate key. And then you could find your points of intersection. It would tell you exactly the same thing. It's just a lot more user-friendly here with Desmos. Comments or thoughts on that last one? All right, let's call it a day for section 3.7.